charge me, and I don't want to pay. Okay. Today, you have to understand horizontal and vertical lines. A horizontal line has a slope of 0. That means 0 is in the numerator and a number is in the denominator to get 0. 0 numerator, number denominator. Okay? If you don't understand that concept, you won't get this lesson. 0 in the numerator, number in the denominator. When you have a vertical line, the slope is undefined. That means you have a number in the numerator and 0 in the denominator. You cannot have 0 over 0 when we're talking slopes, okay? Because that's indefinite form and that's something totally different. So when we're doing this today, if you see it's tangent to a horizontal line, then it's the first one, 0 in the numerator. If you see a tangent is to a vertical line, it's 0 in the denominator. Hugely, hugely important on this stuff to understand that. All right. We're going to take equations like this. And guys, I was watching after wrestling last night. I watched Monday Night Football while doing AP Calc for an hour on this, just so I could make sure I understood this better before I did talk to you guys about it. So let's see if I can do this. Okay? Now, here's the function. It can be shown that the first derivative is this. Oh, they're so nice they did the first derivative for us. What is the y-coordinate of the point where the tangent line is where the line is tangent to the curve is the y-axis? Okay, the y-axis is a vertical line. So that's the n over 0 situation for the slope. Okay, so to meet the conditions for this to happen, you have to have a point on the curve. Duh. Okay, so you can't just put in 1, 2 and say, hey, that works. No, it has to fit for this equation. Okay, now if it's tangent to the y-axis, it must be on the y-axis. So if it's on the y-axis, x equals 0. Yes, Mr. Ricky. We're going on 6 now with 2014. I have it in. Yeah, it's just. I think we did last year because also we had the snow when we had so small numbers. That sounds right. Just wait. I gotta look. That's good enough. That girl is right here. Oh, girl. Yep. I got it. Yep. Yep. Silence. Okay. So since the point must be on the x or on the y-axis, x equals 0, this is huge. This helps us so much when we know x equals 0. The denominator of the derivative must equal 0 because we have a vertical line, vertical slope. So 0 has to be in the denominator. And the derivative cannot equal 0 or we have indefinite form. And we don't want indefinite form today. Okay? So how do we figure out what y is? Okay? Well, to do this, y minus 4 has to equal 0, right? So y must equal 4. Let's see if this works in the original equation. X equals 0, y equals 4. If x is 0, this is 0, disappears. X is 0, this is 0, disappears. If y is 4, we get negative 16 plus 32 equals 16. It checks. Y equals 4. Now this was an easier problem because everything fell into place really nicely, okay? But we will get a little more difficult problems, okay? Now, this one, I didn't include the cheat sheet down below, okay? So, here's the curve. They were so nice and they did the derivative for us. Find the x-coordinate of the point where it's tangent to the x-axis. Since it's tangent to the x-axis, y must equal what number? 0. And then this slope, 4 times x minus 6 over 9 times 2 minus y, must equal what over what? 0 over a number. We don't care what number that is. It's 0 over a number. Okay? So if we multiply both sides by this, okay, because 0 over a number is 0. If we multiply both sides, that disappears, right? So x would equal 6, right? So if we check, because we got to check, 4 times 36. What's 4 times 36? I'm going to need help on this. $144. Uh-oh. 6 is negative. There we go. Whoa. Because I wrote 4 plus 6 here and minus 6 here. So it'd be negative 6 because I was going, something's not going to work out here. So 4 times 36, which is 144, right? And 48 times negative 6 is, I bet, 288 negative, right? Which makes negative 144. So x equals negative 6. Okay? On this one, write the equation of the horizontal line that's tangent to the curve, and it's above the x-axis. So it's a horizontal line above the x-axis, and now we need the equation of that line. Okay? So we're not just looking for an x value or a y value, we're looking for an equation of a horizontal line. The horizontal line equation, if it's a horizontal line, what's my equation going to be? Y equals a number. So I'm looking for y equals a number. What number am I looking for? Well, it's a horizontal line above the x-axis. So if it's a horizontal line, the slope of a horizontal line is 0. Okay? So x must be equal to negative 1. We stick a negative 1 in for x of this equation. 3 times negative 1 squared plus y to the 4th plus 6 times negative 1 equals 253. This is 3 plus y to the 4th minus 6 equals 253. 3 minus 6 is negative 3 equals 253. Add 3 to both sides. Y to the 4th equals 256. What to the 4th power equals 256? 4. Because 4 times 4 is 16 times 4 is 64 times 4 is 256. So y equals 4 is my magic number. That's the equation of the line, which is above the x-axis, because y equals negative 4 may have worked. It wouldn't in this one, but it may have worked. That's why they say it's above the x-axis. Okay, y equals 4. All right. Those, I think, are straightforward. When they do this to you, find out where Kendall made the mistake. It's like, oh, where did the mistake happen? Okay, so here's the function. Did they take the derivative right? Did they list everything they needed to list? Did they solve the equation correctly? Because is it step 1, 2, or 3? Well, so basically we have to do the problem from the start. So if we have to do the problem, what am I going to do to that thing? implicit differentiation. What's the implicit differentiation of this? 2x plus 2x times 2y dy dx plus y squared times 2 equals 0. Yeah. So it's 2x plus 4xy dy dx plus 2y squared equals 0. How do I get dy dx alone? Subtract these two things. So dy 4xy dy dx equals negative 2y squared minus 2x. And if we divide by 4xy, dy dx, if we divide everything by 2, equals negative y squared minus x over 2xy. Does that match that? Yes. Step 1, we're good. Okay. Find the equations of the vertical lines. So if they're the vertical lines, the slope must equal what? Undefined, which means 2xy must equal 0. 2xy must equal 0. So the equation must equal 25. You got that. 2xy must equal 0. Got that. And this cannot equal 0. Got that. Okay? So I think we're good. Because it doesn't, if it would say equals the x-axis or equals the y-axis, we would have to also put down x equals 0. But it doesn't say. It's just all the vertical lines. And so they solved this. So if we put negative 5 into this equation, if negative 5, because if 2xy equals 0, either xs equals 0 or ys equals 0. Okay. So if we put 0 into this equation for y, negative 5 would make 25. That would work. 5 would make 25. That would work. If x is 0, then what makes 25 here? Well, why would, if x is 0, it wouldn't make 25, would it? There's no way that this would make 25 if x was 0. Boom, boom. We found the mistake. 0 isn't an answer. The mistake was in step 3. Okay? All right. Then you'll have a few problems over using your graphing calculator and knowing how to use your graphing calculator properly. Okay? So the second derivative of a function is given by this. Okay? Where is the interval of this function concave down? Somebody type this into their graphing calculator, please. Somebody close by me. And then I can kind of copy it onto this, and then we'll go from there. X to the fourth minus x squared minus x. Okay, so it's kind of a parabola-ish type of thing that goes like this. It trace once. Oh, yeah, it crosses at 0, 0. Trace. And then, no, just trace. And then 0 is 0. And then let's go 1.325. And that's where the other one is. Okay, so it crosses at 0 here, and it crosses at 1.325 here. Okay, the answers are down, so that kind of helps us. Okay, so what's going on here is this is the second derivative. Second derivative tells us concavity. If the second derivative is negative, it is concave down. If the second derivative is positive, it's concave up. It's negative right here, so the answer is this one. Okay, so you got to look and see what they're asking for, then look at the graph and determine increasing, decreasing, concave up, concave down, or whatever, depending on what they give you. The next problem gives me another second derivative problem. Okay, how many inflection points does this have? An inflection point is where this will cross the x-axis, because that's where the second derivative is equal to 0. So please, somebody, put this in your graphing calculator. And the key here is the interval from 1 to 4, because this will go up and down constantly. And then we need to be in mode. We need to be in radian mode for this to work. Graph. There we go. And it is a crazy graph. It goes do 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 woo and do 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 do, kind of like that. Okay, so between 1 and 4, we need to count the inflection points. So on my graphing calculator right here, at 0, we're at 0.5, and it crosses here at about 1, really close to 1 it crosses, and then it crosses again between 2 and 3, and it crosses again between 3 and 4, and it crosses again between 3 and 4. So it goes one time here, one time here, one time here, and one time here. Okay? It crosses the x-axis 4 times between 1 and 4. Now, to do this one, make sure you're in radian mode. If you're in degree mode, it will not work. Make sure you're in radian mode. It crosses it 4 times, which means it has 4 points of inflection, because when the second derivative equals 0, that's a point of inflection. So these are problems to get you ready for the AP test. That is the calculator, because they have 2 sections you can use a graphing calculator, 2 sections you not. You take your mind and what you've learned with your other problems and then adapt them to more difficult problems that can be only done on a graphing calculator. And that's what we're doing here. Okay, ones that are really hard to graph out. Now this one, it gives you the first derivative, and it says how many relative extremum points do we have? When the first derivative hits 0, then that's a critical number, right? And our extreme values, our maximums and minimums, happen when the first derivative is equal to 0. So in between these 2 points, how many times does that function cross the x-axis? And then you graph it out, figure out between 1 and 5 how many times it crosses. What do you see? Does it cross a couple times? 3 sine of x plus ln of x. What do you see, Carlos? Just once? You agree, Andrew? Okay, crosses just once. Okay, so you look at what you have. Okay, first derivative, it deals with increasing, decreasing functions, maximums and minimums. Second derivative deals with points of inflection, concave up, concave down. Okay, so that you're taking what you've learned in this chapter and throwing it into problems that are really hard to do on paper and pencil, but your graphing calculator can graph them out and you can apply what you've learned. Okay, so that is it. Okay, there's a couple more. This one, where is it decreasing? We need to see where this is negative. Okay, and on this one, where is it concave up? What we have to do to this one is we need to take another derivative of this and then graph it and then figure out where it's positive, so it's concave up. So the last section you're going to be assigned does have does have some work to it as far as your brain has to go here. So before lunch, I'll sign this out, and then after lunch, we'll do the Khan Academy review. Okay, they're out there. No, it doesn't. So it's just those two. Yeah. And so then you have to figure out, okay, a -3. This is the first derivative. We'll put in a -3 in here. Just so it's all with calculus. Okay, so if we put a -3 in, that gives me a negative here and a negative here. A negative times a negative is a negative times a negative is a positive. Increasing here, we put in a 0. You get a negative times a positive, which is a. So it's negative here, so it's decreasing here, so the max happens right there. And then I'm sure you're right. Increasing, so the min happens here. Max happens here, so it's going up and down. The min happens here, that's going down and up. So where's the maximum value? At negative here. The maximum value happens where like here. Okay. Are you kidding me? Oh. Well, then you could borrow a charger. Fine. Right. You took one of my boards? Yes. I screwed that. You're right. That's only half the question. I'll read it. No, I don't get that. Okay. Okay. Then you have to check the endpoints because you have to. So -2 would be where the maximum is, the relative maximum, and then you have to check the two endpoints in the actual number. So because if it's increasing going up to -2, you know that won't be the actual maximum. This is the maximum because it'll be bigger than this. Because the graph is going up. Okay. And then going down. So you know this is bigger, but then you have to check 5 in there. Okay. So let's go. Alright. So first derivative of this is -3x squared. Okay, that's first derivative. So then, where is that equal to 0? At 0. So you're going to have to check the points -2, 0, and 2. And sometimes it's just faster to take those 3 points. Take those 3 points and plug them into the original function. So you see which one What?
No, I didn't. I forgot it at home, though, so I can't show you
Okay.
I plugged it in so it charged it because it was dead, and the screen flashing on left there won't turn on.
Yeah. So, yeah, you need to bring that in. But,
Okay. It's really weird.
so 0.8 is the point. No, 0.0. Well, 0.4 would be a point. Negative 2, well, because negative 2 cubed is negative 8, and then multiplied by negative 1 is 8, or yes. So 12 would be our answer. Because obviously 2 equals negative 8. 12 would be our answer.
What?
I want the absolute minimum of that.
Excuse me.
Obviously, 0, so you're going to have negative 2, 0, and 8. The negative 2 into the original function.
David Martin actually accidentally emailed me. Which I don't know how many times I've done.
So then the minimum value, the absolute minimum value, then happens at negative 2. You're right.
Dude, he is your guy, and I really shit him. He's so weird.
Who?
And the only on the scared guy, he will not leave me alone.
No, I don't.
I have no desire to.
Same. For what we enjoy calling that. I like the three stars. Yeah.
You like the swag.
They give so much.
They do. It's ridiculous. I'm so excited.
I know.
Yeah, because Jill and Nina were wearing all these things the other day.
It was random.
I don't even know what to do. Are you ready to? You did not. Jesse, that was literally what you had last time I said.
No, maybe that's really not because yeah. I had that.
So, how do you get your chapters done in the next couple of days? These, not all of them. No, there'd be 3,
Yeah, that's what I meant.
but then that would be.
Okay, voice tone.
That last night,
No, but I'm trying to prioritize. And see if this stuff is in until first, I won't do it. I'm trying to prioritize.
just, yeah,
I'm trying to get on that.
I'm pretty right.
I know.
You are. I've noticed that too.
Thank you. I just and then put it in the work. What should I do about that? I took notes on his highlight semi-annually.
So if we try -1 for the first derivative, makes that positive, and negative, so it's going down here. And then 1 would make it negative, then negative, so positive, after negative. 4 would make it negative, so positive, negative. So it's going down, up, then down. So it happens here or here. So what happens is 0, 5. So when 0 and 5 into this, well, 0 gives you -6. Yeah. And if you put in a 5 here, I bet it's more than that. To do that. -5, -125. It's -125. Plus 75 minus 6. And which would be way lower than -6, right? So that happens at 5. That's where it's up the first time.
You get it wrong.
And then we get to do all 4 of those.
You go on to the next one, and yeah.
At what point?
5 is -6.
It's getting.
0 would give you -6. 2. Oh, maximum value. I look at minimum.
It's fine. Oh my god, we had chopped off the part to put up today.
Yeah.
I'm actually gonna like. Yeah.
I'll just.
So,
What are you doing?
I'm just gonna make my mom do it.
Yep. X coordinate graph closest to the origin. So the origin is at 0, 0. This point is at x. 2 square root of 9 minus x. This is 1.
Literally the
X
same
minus
form
0
behind us.
squared
So what
plus
day are you
1.
Like the first
What?
of
X
December.
minus x 1.
That's like
So
6
2
pages
square
of.
root of 9 minus x minus 0.
Yeah.
So this is x squared, and this is 4 times 9 minus x. Square, yeah. Okay. So then, we have to do the first, we have to boil this out. So x squared minus 4x plus 36, okay? Take the first derivative of this, which is 1/2, which is 2x minus 4 over the square root of this, right? Well, if we set it equals 0, this doesn't matter. Because if we multiply both sides by 0, we get that, right? So then x equals what? 2x minus 4x. 2x minus 4 equals 0. 2x minus 4 equals 0. Add 4. Is x coordinate?
You got a 101%.
No, I did it.
What?
Not a 101%.
Yeah, all this stuff is real. Carson has some videos to get done. Carlos has some videos to get done from back ways. But like that.
Taylor needs to get cooked up.
So this has 200 square inches. There's 2 inch margins on the side, 3 inch margins. So 2 inches on the side, 3 inches on the top and bottom. This is x, this is y. X times y is 216. 16 inches x. Yep. And then, so then this is x equals 4. times y plus 6.
Yeah.
Why doesn't it just sound like
It's like a
There are two
exact code.
small variables. Okay, so that's
But he just put in the extra credit.
Okay.
He did extra
so
credit.
then we have to change one of these into x or y.
Now I have a what doesn't we just
So then let's change the y.
No.
I thought we were.
Plus 4
Are we?
times 216 over x
Mr.
plus
Beersbach,
6 equals a. What?
are we doing a follow-up to this call?
Yeah, we'll do a potluck. When should we do the potluck, people?
Well, it needs to be literally today or tomorrow, or today or Thursday.
Let's do it Thursday then. Do you guys want to have a potluck on Thursday in
For
here?
extra credit?
Yeah.
No.
It's
Not
not
for
for
extra
extra credit?
credit.
I
It's
thought it
for-
was.
So whatever you guys want to bring, we
I thought it
can.
was for extra credit.
No. 5 days for extra credit. That's second semester. So foil it.
I need the extra
216 plus 6x plus 864
But I have like a
over
lot
x
of.
plus 24.
He just doesn't.
I think
Yes.
that's
No, we have one first derivative there, but combine these. 240 plus 6x plus 864 minus 864 over x squared. X equals 0. So 864 over x squared equals 6. Because we have to do the first derivative to find the minimum or maximum. We said the first derivative equals 0.
Everyone else
So
does me like this.
multiply by x squared divided by 6.
We are all
So
like
take
saying
864
the
divided
same
by
shit, and I know. So I don't want to just like.
864.
I don't know. And honestly, I'm not like.
So x must equal
I want to be
12.
super mad about this.
So x is 12, take 216 divided by 12.
Well, if I get a literal boy.
12 by so because of the 12, because you don't, and you check, this is a 12 by 18. So we have to add 2 to the 8, so this is 16.
That question
18
freaked
plus
me out
6
so much. I literally my jaw dropped and I was like, it
12
was.
plus 2 plus
Hey,
2.
what is it? So what do we do?
18 squared is 3. The actual size of the ballpark.
If it's not.
You know how to do this one?
What's your second?
I went over all of these that day. Yeah.
I was like. I don't think it's.
Volume equals
But like,
the area of the base
I've heard of like.
times the height.
No, that's the thing already.
Surface area. The base.
Just gonna use it.
Surface area. Base squared. And the base. Plus 4, because there's 4 sides, times height.
That is.
Then you're good with that. Okay, they give us the volume. 2.5 equals base squared height. So then we're told
Like,
height is 62.5 over base squared. Okay, stick that into this one.
Okay, that is.
Base squared plus 4 base times 62.5 over base squared. Surface area equals base squared plus 4 times 62.5. So 250 over because b squared and b cancel. Okay. So yeah, we're using this to find this. Now this first derivative. So the first derivative equals 0. So
hey, can I have help?
I'm sorry. Okay. What videos? Yesterday's video. I gotta see.
Taylor's like 3 weeks behind me with that. She actually needs help. She's more behind me.
Whose fault is that? Who doesn't come here in the middle of this class period and ask for him to post a video?
I heard someone talking
You. Good.
Oh, saying that you were really annoying and you were always rude.
It was probably you. No, it was probably you.
Are you serious?
Well,
of course.
He's annoying too. He's annoying.
This is really awkward because everyone else is listening to her.
Yeah, everyone's listening.
Announce who the class was.
Okay, did you post that with Sugar Shark?
Nope.
Getting there.
I'm getting there.
Okay, thank you. That's all I needed.
When was this?
I need some help.
Hey, when was that? Oh my gosh, that was recently.
Yes. Oh, I just like that's my head in.
Oh, 0, 0, 9.
Okay.
I got 1 point.
Pre-calc ellipse.
Okay.
J.
So it's x3 times e to the negative x, like that. That's that. So then it's 3x squared times,
Macy's showing on the left.
and then e to the negative x times, negative e to the negative x times
X cubed.
Gatekeeping.
Wait.
Wait.
Oh, that's
Yeah,
it.
you did the negative one.
Yeah.
But are you taking the first derivative of this? Right. So it's times x cubed.
I just wanted to know if I had to do the chain.
Yeah, it is a chain rule, and you did it properly.
And then how do you find like x equals like the critical?
Critical numbers, set it equals 0 and solve. So then you factor out an e to the negative x and then an x squared. And then you're left with whatever.
Wait.
Cal, come back.
What do you know?
What do I do now?
Really? You do the quotient rule with that?
Yeah. So then this is 2b plus negative 250 b squared. B to over b squared, right?
Oh, what? You don't do the.
Yeah, this is b to the negative first, right? Yeah, this
Oh,
is
you want me to
250
move it
times
up.
b. Yeah, it's easier to do it that
Okay.
way.
You come up there when you get time.
Yeah. I'm not going to get time before the bell rings because it's going to ring in 1 minute.
We're first bell, right?
Yeah, we're first bell, so it's like 45 seconds away.
Dude, that's actually
Kids, you gotta get a regular sleep schedule. Get your circadian rhythm within check. But
That's just not a bad word.
Okay. Don't have to worry about that. Inbox. Let's see.
Tanisha John, come to the office. Tanisha John, come to the office.